Space and Rocket Review. Space and Rocket Review. You two girls, tell your friends. Space and Rocket Review. And it's Ladies' Night at the EJSA Mission Control. Tell your friends, one night only. The fantastic Space and Rocket Review. Good news, the new Dacias are in. What's going on, everybody? How you doing? Welcome to the Space and Rocket Review. It is Monday, July 13th, 2026. And I'm EJ, I'm your host. I'm the only one here. I'm not gonna lie, no one else is here.
Discovery, go and throttle up.
No, we're good. I don't know. Weird. Hey, flip up 55-month resub. Arbalest 80-month resub. I call fake news. There are no ladies on the internet. New relativity video. Oh, I will add that. I actually didn't have that editor. I can just get it right now. I don't think that's right. You know, I don't think that's correct. But whatever. You know, it's the internet. You can make the algorithm makes the internet your own, right? Or something. Okay. How is the gazebo in the house? So, I have nicer gazebos, and then we have pop-up tents. I had some pop-up tents because I had a party over the 4th of July. I just hadn't taken it down yet. And the pop-up tent is what went flying. It went flying into the house. It's fine. It was an Ocean State job lot special, dude. Don't worry about that. It's actually not. It only tore the canvas just a little bit. Other than that, it's mechanically pristine. So yeah, house is fine. Gazebo's fine. Everything's fine. Just, you know, this is the gazebo update for Space News. So all the nice gazebos are all staked down, you know. I told you I staked them down because it was the gazebo that failed. I thought the tent failed, or I thought the gazebo failed, not the tent. Gazebo is much nicer. It's metal construction. Okay. Gazebo almost went orbital. Yeah, it was close. Alright, so I guess we have a new relativity video. We can't watch it with sound because YouTube will flag it, but let's see. Let's see what we got. We'll put on the closed captions here. Terranar update, June 2026. June was a big month for the Terranar program. Let's take a look at key progress across the design, build, test, and launch. This month, the team released 2,238 flight parts. Engineers remain focused on the first stage, releasing nearly all components required for the first stage shipping assembly, including fluid structures, avionics, and harnesses. This design sprint unlocked downstream integration on the first stage, with teams progressing. What? Hold on. With teams progressing stringer and doubler drill operations, installing stringer, joiners, and drilling raceway brackets on the thrust structure. Okay. Nice crane hat. Yeah, I think you'd like that. Okay. The team is advancing fluids builds ahead of avionic testing and leak checks. All vehicle structures and closeouts were completed on the stage. Stage 1 qualification article, and it was officially handed off from manufacturing to factory testing. The article was transported to the parking lot using 2 heavy lift forklifts, where it was lifted onto the structural test atop a base barrel. Teams then installed the load head and integrated ropes with large axial actuators, which apply compressive loads to the tank. After activating the water system and conducting initial checkouts, qualification officially began. With initial proof test cases successfully completed. The tank will undergo proof cases with mechanical and pressure loads, life cycle testing with repeated pressure cycles to validate durability, and ultimate loading cases to provide ultimate strength capability of the tank in a pressurized environment. Meanwhile, the second stage arrived in MISSI after passing through the Panama Canal. The transport vessel arrived in Gulfport, Mississippi, where the stage was transferred onto a barge to hardware. The hardware continued its journey up via the Pearl River to Nassau, where it was unloaded and taken into the nearby hangar. Inclement weather couldn't hold the team back, who persevered through unreasonable conditions. In parallel, teams on the ground at Nassau readied the hangar and the A2 test stand for Stage 2's arrival. The diverter arrived on site and was transported to the test stand. Whoa. Tally. 24. What's going on? Nice pipes. Look at that thing. Oh. Hello. Where it is now being installed. Launching pipes. They say you can hear launching pipes. Measuring 97 feet long and weighing 1.4 million pounds. This critical piece of hardware protects the stage and test infrastructure. Holy cow, look at that thing. That is it. That is very nice. Stand's access platform was also raised into position. Very good. And hold downs were installed. Progress on these critical pieces of infrastructure brings the A2 test stand closer to activation ahead of its upcoming Stage 2 hot fire campaign. On the R stand, acceptance testing for all Flight 1 Aeon R first stage engines is complete. And acceptance testing for the Flight 1 Aeon 5 second stage engine has begun. At Launch Complex 16, the pad and surrounding infrastructure continued towards operational readiness. 60,000-gallon water tanks were installed at the water farm, and tanks were activated at the liquid oxygen tank farm. Crane installation is underway at the horizontal integration facility. Cranes. And the lower portions of both lightning protection systems are complete. Launch table construction is ongoing with construction work on the breezeway and approach road. This month, we also announced the Interplanetary Jared Isaacman. Interplanetary Science Program, an initiative to enable radically more science per dollar. I actually kind of like the white on white. White tank, white text. That's it's pretty flashy. I like that. By building the next generation of interplanetary capabilities that make discovery more capable and accessible, the program's first mission will be a Mars Science Orbiter launching in 2028, flying Relativity and NASA-developed payloads. Both Terran-R and the Interplanetary Science Program ladder up to Relativity's larger vision of expanding high-cadence access to space and advancing science. Stay tuned for more updates on our journey. American flag. Very quick PLD update. I have PLD stuff on here. All right. Now what I'm going to do is go back through it without annotating this thing, and I just want to look around. Let's see what we got. Ooh. A lot of good stuff. Oh. Oh, HyperX headset. Just saying. Hello! Somebody gifted God Saveth the Queen a tier 1 sub. Alright. It's LC16, Zintos. This is Relativity, not blue. No sign of the TE. It's probably being manufactured off-site. Yes, very good. Look at that piece. Nice. Okay, stringers are internal structure that or external structure that make the stage more rigid, and doublers in aluminum construction are just plates that are lapped on top of each other. It's doubled up aluminum. You would use that also in places where that you want to be strong. Raceway bracket drilling is the avenue for electrical wires to go up and down the stage. It's being built on the Cape. It's being built on the Cape. Sent you something Pawn Discord. Yeah. I have that already. Don't worry about that. Oh, don't you worry about that. I got that already. Thrust structure is looking pretty good nowadays. Being caped on the build. Dude, look at that damn flex joint. I would say how expensive you think that flex joint is, but yes is the answer to that. Yeah. Yeah, Paranar is going to be pretty good, man. Yeah, see these? See those ridges? Those are stringers. Very nice. What's the green around it? It looks like it's still in the package. It looks like plastic wrap, yes. Terran-R is going to be bigger than Falcon 9, guys, and the reusable capacity will be able to deliver what Falcon 9 delivers in expendable capacity. This is not a small rocket. So this is a stage 1 qualification article. This is basically your qual article like this is, for all intents and purposes, for the most part, a flight test article. It's like your final exam before you actually go to launch, right? This is basically the real deal, minus one or two things here and there. Obviously, it's not painted. And this, usually qual articles have a lot of room for sensor suites and sensor packages. That's what all this stuff is up the side. Those are most likely strain gauges to make sure the stage doesn't stretch or test its stretching qualities, like when they go to pick it up and bring it vertical. Sierra Space News, hot off the press. Okay. Yeah, see, all this is developmental instrumentation. So like it's kind of like it is a real booster, but it's got all of its guts hanging out on purpose. So like all the wiring is just kind of hanging on the side instead of inside of a nice covered raceway. See all the sensors, all the strain gauges. I mean, they might not just be strain gauges. It could be for other things. So what they're going to do here is this is, for all intents and purposes, this is a gigantic press. They're going to pull on these bungee cords and crush the thing. And what you're ideally looking for...
This is Space.
Space Pulp! Gifted 5, thank you. What you're ideally looking for is whatever your analytical load factor is. For this, you're looking to basically get to it and make sure that it doesn't pop when you try to crush the thing. Yeah. This is more or less mimicking max Q plus or minus a little bit more. Maximum dynamic pressure. So maximum dynamic pressure in a rocket's ascent trajectory is peak aerodynamic load. That's basically the most compression force gets put on the vehicle at that point, right? They're probably trying to get to that and then a little bit more. So what's going to happen is these are on hydraulic actuators and they're going to pull it down and they're that qual test is going to crush the thing. I mean, it's probably already happened, but you get the idea. It's probably not 150% J speed. It's probably a shade over what they're encountering during max Q. Probably not 154 though. The margin for max Q is not as much as you might think it is. Like, actually, maximum dynamic pressure and compression load is actually, I would say, I mean, Lava Eagle, you correct me if I'm wrong. I would say that that's probably one of the easier things to figure out. It's your orbit day. Well, happy birthday, Space Pope. You're the ripe young age of 29, right? Right? See me, I turned like the other day. The ripe young age. Yeah, right? That's a number. Is this Falcon 9 2.0 or Falcon 13? Falcon 13. If the Pope is in the woods, does it even age? That's right. You don't know. How do you know? You don't know. You don't know. It's like how positive traction works on a 72 Plymouth. You just don't know. It's just science, okay? 42. Well, don't forget to bring a towel. If you say to young people I was born in 19, they look weird. Yeah, I've seen those videos, Daitor. It's just goddamn kids. Get off my lawn. Yeah, and you know what, Daitor. Here's what you say. You know what you say if somebody goes to that. I was born in 1988, right? They're gonna go, oh my god, it's so old. I'm like, yeah, I'm age mogging you. Get fricked. Get out of here. Yeah. I know your stupid speak because my job's on the internet. Boom. Age maxing, son. Now what? And that's when they'll be like, it's awesome. The rot. Yeah, there you go. Yeah, you just see. When I was a kid, I always thought it was funny because we had millennials speak, right? It's like leet hacksaw, and adults are like, yeah, I don't know what that means, and it's like, yeah, I know you don't, right? But I understand the language. We invented quirky humor, all right? We invented it, all right? All right, we invented it. I tell you, back in my day, we invented the weird speak, right? Yo, this rocket is tight, son. Nah, I mean. So, believe me, you have to out brain rot the kids and they will get very confused. And that's hilarious. That's really funny. Get age mogged, son. Anyway, moving on. Yeah, so see the actuators down here, they're going to pull down on that thing and try to crush it. Or, well, it's not really kind of crush it. They don't want to crush the thing. The idea here, this is a form of NDT. It's called non-destructive testing. Non-destructive testing is, well, you want to crush it as much as you think you're going to see it get crushed on an ascent and make sure that it doesn't pop. NDT is what it's called. No, not Neil deGrasse Tyson. Non-destructive testing. It's obviously not engaged because the straps are blowing in the wind. But see all the extra sensors and everything that they have? On all this, it looks like, I'm actually not sure what those are. But, yeah. There's they really seem to put a lot of sensor packages on the stringers. They're looking for strain at the common bulkhead from what I can tell here. See all these? These are trying to measure how much compactness you're going to get here. Wasn't weird speaking invented by the Scots? I don't know. Sadly for Neutron, it became destructive testing. Yeah, that's right. Oh, that's that side right there. That's the west side. It's the negative Y axis of the vehicle. You can tell because of the way it is. That's pretty neat. All these pictures from when they weren't doing testing. So these are the locks going into Stennis. The relativity second stage looks really tiny here because the Saturn V stage was designed to go up this thing. So yeah, it looks kind of tiny going through the locks, which is funny. That's the old A2 test stand from NASA. They put the diverter in and they're going to test the second stage on it. I don't know how you're going to test the second stage. You're missing a piece. Because we got no engines, Ted. Do we? couple of ARNRs will pull a premium right before test flights. What are you thinking, chat? Methalox? Hydrolox? Hypergol sounds good. No? All right, cool. No, it's fine. Cryo first, they might need to finish the diverter before static testing. Yeah, it's finished. What were the propellants on this thing? I believe it's methane or LNG. Actually, it's mostly LNG. What does Past EJ think? We don't talk to Past EJ right now. Okay. Hey, EJ, is that what they tested the big one, the world's biggest solid motors? I don't know. I don't know, man. The A2 test stand is where they tested Saturn V second stages originally, and then it turned to shuttle engines, and then, yeah. This is a service gantry, basically, so they can close the gantry over the trench, right? See, it's like it was working like a gantry crane. It slides over the trench so you can install the rocket engine. Makes it easier to work on. It looks like Relativity is taking the A2 test stand and making it so they can test first and second stages on it, but that's just a guess, though. I'm not entirely sure. There's a bunch of scaffolding up here, which looks like they're working on the plumbing for those. So all the engines for the first Terran R flight, including the upper stage engine, that's why they shipped the upper stage with no engine, because it's already there, are ready to go. That's the second stage motor right there. It's an Aeon V. So V for vacuum. This is at complex 16. Yeah, the upper stage engine doesn't have its vacuum optimized nozzle because it's not being tested in the vacuum. NASA did have a test stand where they could do that, but they decided they built it and then they didn't want to use it anymore. So, you know, that's great. Gantry crane. 2 cranes, 4 horizontal integration here. There's the lightning towers. You know, dudes, those things look awfully similar to the lightning tower that just got leveled at Launch Complex 36. They, I wonder if that's the same contractor or the same design. Maybe they got them off eBay, dude. Yeah, exactly. You know? Hey, what's up, Petrie? How you doing, man? What's that big bubble on the bottom of the engine? It's a manifold for recirculating stuff. And yeah, Jared Isaacman was up there with the looks like the first flight test stage, that white on white text stage over here. That's a flight test stage. It's got all the thermal protection on it. The qualification article had none of this stuff on it, and it wasn't painted. This one is painted, and that's why I like the white on white. The white on white looks good. The AJ-260, those were tested in the Cape and giant missile silos, and those were 10 meters in diameter. No, that is entirely wrong, on multiple levels. No, the AJ-260 is 260 inches. It's a 260-inch diameter, single segment solid rocket engine. It's single casing. It's 6.6 meters in diameter because it was supposed to be the first stage for the Saturn 1B, and it wasn't tested at the Cape. It was tested at Aerojet's facilities in West Palm Beach. It's a good ways south of the Cape, not even close. Like, we're talking like down near the bottom of Florida, not the center of Florida. That's yeah, that's wrong. I'm like 100% sure. And it was really only tested, I think it was tested like once or twice. And even then, what they tested with, because they just didn't have a big enough test stand, was half. They tested half of an AJ260. The actual AJ260, had they gone with it, would have been double the length. Same diameter, though. Well, now I know what channel not to watch. Sorry. Someone didn't do the research. 58 Racer, what's up, man? 17-month resub. If slick is slick and LC, is LC therefore lick? No, LC is just launch complex. You getting pumped for Flight 13? Yeah. See, there's the, that is the engine section for that white, the first stage that Jared Isaacman was standing in front of. Note here, guys, that their engine, so I often talk about rockets tooling and stuff and how you're trying to tool for scale, right? So, a little bit of interesting thing here about the jig that the machine that builds the machine that I noticed when I was talking. So check this out. There's another cell over there for working on another engine section. So this supports the processing flow of building up to 2 engine sections at this phase in integration. If I had to guess, this is probably first stage main propulsion system final assembly. They can build 2 at once. That's not incredibly special by any means, but that does mean that they could build 2 at once, indicating that right there is a flight hardware way of saying that Relativity is trying to build a lot of these things. You wouldn't, if you were aiming for a lower production output, you wouldn't have 2 engine cells here for, you wouldn't have 2 integration cells here. There's no point in having 2 if you're not going to build a lot of these things, or at least plan on building a lot of these things, just for what it's worth. Well, this is too strange not to share. Erling Haaland arrives back in Norway with a raccoon holding a liquor bottle. Okay. Yep. All right. Not this one. It's another one. I love this channel. I know what you meant, Ator. Yeah. Just hopped in. What is this? Relativity. This is a Relativity space update. A taxidermized raccoon. Yeah. Hopefully it was taxidermized by Chuck Testa. Nope. Chuck Testa. If you got it, good for you. We're friends now. Nope. It's just Chuck Testa. Nope. Chuck Testa. Hey, that was a good meme when it came out. That was really funny, all right? Nope. They're not alive. They're dead. They've been taxidermized by Chuck Testa. Probably thought that raccoon was alive. Well, it isn't. It's dead. What is the purpose of the slide? To divert flames? That's called a flame bucket? Yeah. So, okay. Zintaus, that's a good question. Think about it like this. All right. I don't think I need to say that anything that you put underneath a rocket engine or put behind a rocket engine when it's firing, you're probably going to lose. So, how do you test the damn thing? Well, you're going to need a test stand, all right? Now, there's flame diverters, right? And then there's what I call a flame diverter, right, is just a deflector. You know, just a flat piece of metal that deflects the flames out. Those work, but also eventually it won't, because metal gets hot and it melts. Rocket engines put out a lot of heat. You get the idea. Diverters are cheaper to make, but they have a shelf life. Okay? That right there is a flame bucket. What's the difference? A flame bucket is made out of a bunch of brazed pipes all together in the shape of a flame diverter. That thing is actively cooled. So because water is such a fantastic heat sink, you can put an amazing amount of heat energy into a volume of water than you could on a lot of other things. It's very conductive. And even after that, it can conduct more heat even after it's evaporated into steam, right? that is a good way to basically run water through the test stand and have it pull all the heat out of the metal. A flame bucket is an actively cooled flame diverter. That's how I think about it in my nomenclature. I'm sure someone's going to disagree with me, but you really need the NASA patch. Yeah. You're not going to get it here. I'm not NASA. I'm friends with them, though. Would you consider the milk stool for the Saturn 1B as a flame diverter? Would I consider the thing that has a different name than a flame diverter a flame diverter? No, I wouldn't, dude. The phase change soaks up even more heat, as I understand it. Yes, water is a great heat sink. So think about this. All right, you have a pad, right? And your pad's only going to see the rocket engine firing on it for what? 5-10 seconds maybe before it leaves, right? Launch pads are not designed to handle long duration burns. There are exceptions to this rule. I'll tell you in a second. They're not designed to handle long duration burns. That's not really what they do. They're only designed to handle the launch for a couple seconds, right? And then you're good. That's why you'd go with a diverter for your launch pad, right? Your test stand is designed to do full duration burns. So a second stage in any particular orbital rocket's design is going to burn anywhere between 6 to 14 minutes, depending on what type of upper stage you wanted, right? Yeah, like Centaurs are capable of extremely long burns. The Falcon 9 second stage, like a Merlin vacuum, does a 6-minute burn, more or less. It changes. It varies with the mission, but you get the idea. So test stands need to be able to handle it. So what they do is they carry enough water in this thing to be able to shoot water into the flame bucket for 10, 20, 30 minutes, right? And then you just turn the engine on, provided you have enough fuel and oxidizer, and you can test it indefinitely on the test stand. Now, like I said, there are exceptions to this rule. A big exception to this rule would be Starship. Super Heavy. Starship's launch pad. That has a flame bucket. It has a dual deflector flame bucket. Why? Why would it do that? Think about it for a second. Why would SpaceX opt for that instead of just a diverter? Really think about it. What did I just tell you? What are flame buckets designed for? Long duration burns. Massey's, the Starship test stand at Massey's has a long duration burn. The Falcon 9 acceptance testing stand at McGregor has a flame bucket like this. That's designed for a full first stage burn, right? Hey, Matt, what's going on? 1413 some. I'm excited for Flight 13. Me too. I have a whole section planned for Flight 13 in Starship. Launch plus landing. That's a good point, Blackness, but that's not the exact reason. That is a benefit. I would say partial credit. Partial credit where credit is due, bro. YouTube chat beats you guys to it, man. Telstar over there. SpaceX's pads are used for testing. They're used for testing Super Heavy. Long duration burn. Well, longer duration burn. We know that it can handle up to a 24, 25 second burn with Super Heavy. Now, 24 to 25 seconds doesn't sound very long, but if it's 33 Raptor engines going full blast, yeah, that's a long time to be blowing down at a flame diverter. It would just melt it. So that's why SpaceX opted for a twin flame bucket design for their diverter instead of just a kind of a bone stock diverter. Does the water turn on when the booster comes back for a catch? Yes. Yes, it does. The top deck. So, all right, while we're here, a little bit on pad nomenclature if you want to understand this. So there's sound suppressors and there's pad deluge systems, okay? Generally, this is very generally speaking, guys. This is not... It's not always this way, and there's no real standardization here, but this is, if you read any aerospace engineering textbook on water systems and the application of launching rockets, it would tell you this. So there's a deck, the pad deck, right? Anything above that right? So the rocket's usually sitting on some kind of structure. Whatever that structure that the rocket is directly sitting on is called the pad deck. Anything above the deck is a deluge system. Anything below the deck is usually called a sound suppressor. That does not necessarily mean that you can't have deluge systems in your design that's below the pad deck. That's just kind of, if there was standardization, that's what I would call it. Now, Super Heavy does have a deluge system that sprays inward from the top deck and ends up splashing down into the flame trench. We could see it right before Super Heavy fires, right? And then we saw in the Critical Path video their main deluge system, which shoots up out of the top of the pad deck out in all different directions to protect the pad when they go to lift off. And then anything in the flame buckets down there, there's the the cooling, the diverter cooling, the flame bucket cooling, and then there's additional sound suppressors at the end of the bucket that shoot up to basically quench the sound. I mean, there's only so much that you can do when you have 33 Raptor engines firing. It's not a lot. Like so, I mean, it works, but it's, there's only so much you can do. And whatever, they're sub-Sharpie per the Critical Path video. SpaceX did release a new video, guys, just in case anybody's wondering. They released a new video in their Starship docuseries. It's called Critical Path. I did a review on it. I watched the whole video, and we watched everything on Friday, and that's a VOD that's up on the YouTube channel. I have a whole breakdown through the whole thing. I did it right before Flame Trench. Time to hydrate. Also, the choice for a twin bucket rather than a single bucket could have been because the twin configuration gives you more area and the angle at which the exhaust hits the bucket is lower, so less heat flux. Possible, but that heat's got to go somewhere, dude. But yeah. How's the air conditioner? Oh, yeah. Other quick bit of news, guys. Yeah, throughout playing Satisfactory this afternoon, looking at the Pillar of Autumn, I have my mini split installed, and it has stayed at 72 Fahrenheit in here, which is about 20 C. But dude, look at how much humidity it took out. Holy crap! 20% relative humidity. It was 70 when I came in here. So, yeah. If anybody doesn't know, I have a mini split installed. It's a Mitsubishi P Series, which is. It's not a residential mini split. That thing is really designed to cool server rooms. And it's 18,000 BTUH. It's a little overkill for what I'm doing here. Yeah, right, Lev, for sure. So Shaw, just to see, I ended up leaving the door open into the shop and then left that thing on, and it legitimately with no problem cooled the entire shop. I came up to the shop this morning. I went inside. I was like, damn, dude, it's freaking cold in here. Yeah. I set it to 65 degrees Fahrenheit, which is like 16 or 17 C. The whole shop was that. Yeah, the whole shop. And I was like, my electric bill is probably not happy right now. But see, here's the thing. Because I'm telling you this story of my colossal screw up, I can write it off. So we're good. Yep. So, you don't have to worry about that. Show the mini split, then write it off. No, it's good. Are you ready? Battlefield Intel. Oh, Server Reef, nice. So it was an exercise of tax experimentation. No, not experimentation. Not experimentation. This is a totally legitimate business strategy. 6,000 BTU is a 250 square foot room, so 18,000 BTU. Dude, I went and looked. It's enough to cool the volume of structure that's four times the volume of the shop. So I don't think we ever have to worry about heat in here ever again. At least in the summertime. Like, yeah, we don't ever have to worry about it. Everything is going to stay nice and cool in here. Now install some solar panels and your electric bill will not cry. Fortunately, I live in the woods, and there's these things called trees. Yeah, it's kind of hosing me on that front, dude. Can you make it snow inside? I'll bet you I could. Yeah, we'd have to jailbreak the thermostat, but, you know, whatever. Or just tell it. I mean, I don't know, whatever. Wait till you start welding. I am not entirely sure that the welder and the mini split are going to cooperate correctly in this circuitry. The heat pump's 30 amp. I have 50 amp service out here. It might be prudent to shut that off when we're doing welding and then cool everything back down. Yeah, the welder is going to pull more than 20 amps. It's going to pull more than 20 amps, yes. Just build a tall tower and put solar panels on that. Oh, yeah. Yeah. What's the model of welder? It's a Lincoln 180. It'll pull more than 20 amps, dude. It'll pull more than 20 amps. You can only choose one. Yeah, exactly. The draw is variable on the mini split because I can control it. So if we could get the shop cool enough, weld, and then turn it back on. Or see if I can find a setting for that thing that makes it happy to work with the welder. Just don't need to burn the place down. You know. Does it pull 180 amps? No comment. All right. Probably only got another 3 to 4 weeks of the worst heat, though, right? Right? Yeah. Anyway, let's jump back into space news. Check this out. Last week was the 15th anniversary of STS-135, the last shuttle mission. And Doug Hurley posted this, got the crew back together. So that's Chris Ferguson, Sandy Magnus, Doug Hurley, and Rex Walheim. Those are the final 4 people that flew the Space Shuttle Atlantis in July of 2011. And they're, of course, at the Kennedy Space Center Visitor Complex, which is pretty cool. Yeah, there's a reunion of the crew. I personally, if you really want my honest opinion, I think that shouldn't have been the last shuttle flight. We should be on like STS 260 at this point. But we chose to just not do cool things for a change. And you know what? That was dumb. We should go back to doing cool things. Speaking of cool things, I mean, we are for the most part. But yeah, here, speaking of cool things, check this out. Tori Bruno posted this. The first Blue Ring super spacecraft continues to move smartly through assembly. But I thought I'd share some pictures of the other vehicles that we built as dedicated test units. This is the static test vehicle doing its thing. Ooh, Blue Ring. What have you planned for Starship Flight 13? At this point, Meridius, it's stream it. Yeah, stream it from here. That's the plan. They're doing some type of load test simulators on these things. So What Blue Ring is basically a modular satellite where you can attach different pieces of it for different applications, and they're testing the attachment fittings here. Yeah. What applications? Well, I don't know. If we go look at Tori Bruno's job title, there probably is probably an indicator of what types of packages would be attached to these Blue Ring satellites. I don't know what your elevation is. It's sure solar could give a good return for 6 hours a day. Man, I said I didn't want solar panels, and a lot of people took that personally. I don't want solar panels. There's trees. There's trees in the way. Like, there's trees. A lot of them. I live in the woods, and I don't feel like clearing trees. You know what I'm saying? You're nothing. All space-related hardware in the future will either be star blank or blue blank.
Discovery, go at throttle up.
I know. Anyway, we got an update coming from PLD Aerospace. PLD is a Spanish smallsat launch provider. And they're working on their new vehicle, Mura 5. Let's see what we got here. Probably can't listen to the tunage here. Mura 5. The Mura 5 tanks in action. Pressurization system stability test under nominal propellant flow conditions. Test stand number 3. Okay. A 200 amp run to the garage would be quite useful. Yes. Particularly in 3-phase. 3-phase 200 amp would be very nice. You know, for reasons. First stage fuel tank. Okay, so what PLD is doing here is testing flow through the tanks, but they're using water. No, I swear the tank isn't just is not taking a pee on the side there. Don't worry about that. Oh, don't tell me they're gonna dump all the locks out of this. Yep, they are. Okay. One to 3-phase converters are pretty cheap, right? I don't know. I haven't looked. All I know is that in the future, I might want equipment up here that's, you know, needs 3-phase. That's all I'm saying. Cool. Now, I can't help but notice, guys, that test stand is a little bit taller than needed. Wonder why. It looks like they're doing interstage load testing over here on this stand, for what it's worth. Expensive fog machine. Yeah. Yeah. They put a bunch of concrete blocks down to divert the locks this way. Interestingly enough. That's good, man. This is more or less qualification testing on their stages, so pressurization system stability test under nominal propellant flow conditions. Pretty cool. That's cool. Good for them. All right, so check this out. We're going to switch gears from the commercial providers here.
Go at throttle up.
Revue, 32-month resub. Thank you. You missed a thermal shot. No, I didn't. I saw it, and I acknowledged it, and I moved on. I just didn't tell you about it. I want to move on to the next news. Yeah, commercial Europe. Yep, PLD is Spanish. Regarding the taller test stand, they do have a larger rocket called Mira Next, but that's very, very far off. This is coming from NASA's Artemis account. The pieces for Artemis 3 are starting to come together at NASA Kennedy. Twin solid rocket boosters, they're getting stacked. The launch team, they're simulating the countdown. The heat shield, attached to the Orion spacecraft. Full steam ahead for Artemis 3. It's Charlie Blackwell Thompson, launch director at Kennedy. Those are some dudes and a chick under the mobile launcher with the solid rocket segment stacked. Hey, all right. Thanks for your streaming in monetizing, reviewing everything there is in the space community and beyond. Will you join NSF on the 16th? Marides, I like, once again, I appreciate the kind words. I don't really have an answer just yet. I'll get back to you. But yes, I will. It will be either here on NSF. What I'm most likely going to do is sorry, my brain just blanked out because I'm looking at two aft solid rocket motor segments. Well, that's pretty neat. It'll probably be NSF hybrid combo. I like doing the stakeout stream for NSF and then coming here and covering the Starship launch that way. The chair is there. I have it on very good authority that the chair is overseeing the stack. Here. See? I have it on very good authority. You could see development at Mila for a GS2 hot firing stand if you drive on Florida 321. Piles are being driven. Ooh, yeah. Yeah, that's a good idea. Is rocket fuel expensive? No, not really. Russ, it's expensive for you and I, right? But when you're spending millions of dollars on a launch vehicle, it's not very expensive. There's the chair. Get your head out of the flame trench. Get your head out of my flame trench, bruh. Bruh. Any of you asked Jared about the chair. Jared doesn't need to know about the chair. Don't worry about that. Yeah, there you go. So Artemis 3 has started to get stacked. That's Randy Bresnik and Andre Douglas right there. When do you expect a full stack of SLS? End of this year? Oh, no. Probably end of the summer. I would guess probably by August. Yeah, they'll have it good to go. Oh yeah, easily. So, that's pretty cool. All right, what else do we got here? So, this is coming from the International Space Station's account. We have MS-29, Soyuz MS-29, which will carry NASA astronaut Emil Menon and Russian cosmonauts Peter Dubrov and Anna Kikna to the International Space Station at 10:47 a.m. Eastern on Tuesday, July 14th. Frick, that's tomorrow. Give me a second. Yes. Is it a lot more expensive than jet fuel? No, not really. Oh, well, looks like we're going to be here early tomorrow. Nice. So this is Emil Menon's first flight. There's a picture of the MS-29 stack. And, you know, here, let's just...
Discovery, go at throttle up.
It has a advertisement for an energy drink on the side. Seven, 55-month resub. What's up, dude? Is an orange tank done? Is the orange tank done on 4? Yes. Well, the engines are being integrated in the next high bay over, Sea Kraken, so it'll be done soon. That's an energy drink advertisement, and then looks like a bunch of children's drawings on the second stage, which is pretty cool. That's kind of neat. But also, there's an advertisement for an energy drink on the launch vehicle. Look, I like NASCAR, like Formula One. I don't mind, race cars and stuff having advertisements on them. Please, for the love of God, do not stop doing that with rockets, and don't ever do it, ever, period, full stop. Like, that's gross. That's disgusting. It reminds me of the Zvezda launch in 2000. No, that is not photoshopped. That's real. Caveman, please no. Yeah. So, time, what I'm trying to tell you is that time is a flat circle. Is Roscosmos having trouble funding their space program, or I don't really understand what's going on here. Are you having a little bit of trouble there, buddy? We know the answer, but shh. That brand is broadly advertised in Russia from YouTubers and TikToks. As you can guess, people below 18 watch them. Lovely. Okay. What else do we got? What's this, Baron? This abomination will fly soon. Oh, we also got to get the Sierra Space News in here. We got to get the Sierra Space News. Oh, look, Sierra's posting about something that isn't Dream Chaser. Wow. Didn't see that one coming. Let me guess, it's for defense. We are thrilled to share that the Space Development Agency has awarded us a $798 million contract to design, manufacture, and deliver 18 missile warning tracking satellites for the Accelerated Missile Defense Tranche 3 AMDT3 program. This award expands our role into America's space-based missile defense capabilities, leveraging our proven Sierra Space Eclipse TM satellite family technology. From our Victory Works facility to orbit. We're delivering the speed, scale, and reliability the warfighter requires. Oh, look. A box. That's great. Stackable satellites. I haven't seen that before. What's in it, though? Don't worry about it. The advertising on the side is real, yes. Yeah, that's a real picture. Also, that is a real picture. Doubt they would ever be allowed to show the full satellite. Yeah, I know. Wouldn't it be? It would be really nice if they, you see our space. You're like, here, let me show you. Oh, look, what's front and center? Their space station modules and Dream Chaser. Those are two things they just never talk about or post anything about. That'd be really cool if you talked about that, but they just missile detection. There is nothing. I'm scrolling through their feed here. There is nothing about Dream. Oh, there's one from April. Okay. All right, let's stop doing that before I get annoyed. Let's see, what do we got? Northrop Grumman, our mission robotic vehicle, the nation's first multi-mission robotic servicer in space. Okay. Built in partnership with DARPA, the Defense Advanced Research Project Agency, and the National Reconnaissance, they tagged the wrong person. In the National Reconnaissance Office or the National Rugby League, it could be either one, whatever. That's what they want you to think. That's right. You walked right into it. I was like, wait a minute, that's not the national, is it? All right, whatever. Along with 3 mission extension pods or satellite jetpacks, is scheduled to launch with SpaceX no earlier than 5:15 p.m. Eastern Time on Tuesday, July 21st. Oh, that's next week. Okay. Somebody at Northrop Grumman likes rugby. That makes sense. Yes, I'm here to work on the rugby robot. It keeps unfollowing me from Northrop Grumman. I don't know why, but... Gee. Multi-mission robotic servicer in space, built in partnership with DARPA and the NRO, along with 3 mission extension pods or satellite jetpacks. Won't read too much into what that does, but the NRL team is going to orbit. Let's go. Wait, which national rugby team? Which national rugby league is that? Yeah, it's Australia's national. Yep. Okay. All right. I want to read the comment section here. Is any? Oh. Nobody noticed this. Nothing? No. All right, whatever. Whatever. It's fine. It's fine. Next, let's go back over to the Soyuz launch. MS-29. So Jared was out there. He's out there with Anil, which is pretty cool. Jared showed up to Baikonur. That's the first time a NASA administrator went out there since Jim did it in 2018. That is the Soyuz. It's very nice. That also is the Soyuz. That's the new, see this piece down here? That's brand new. The launch integration stands. This is all brand new. See, if you look at this picture, this is the piece that actually flew out of the launch pad and crashed really recently. If you look, this whole structure right here is on a gantry, and if you look, there's a room back there with a bunch of lights. It actually retracts into that room. This is for servicing the engines and installing the launch igniters. Yeah, it's a servicing platform. And once again, that platform is brand new. See, it's all shiny. And Neil is Anna's husband, right? Yeah, and if you've heard the Menon name before, it's because, yeah. And Neil became an astronaut. Which class was he in? Became a NASA flight surgeon in 2014. Yep. And then he served as SpaceX's medical director in 2018 and its first flight surgeon. He was present at 4 Crew Dragon missions from Demo 2 to Inspiration 4. And then he was selected to be an astronaut in December of 2021. He reported for duty in January 2022. The interesting thing is he became an astronaut, and his wife, Anna, who wasn't an astronaut at the time, flew into space before him with SpaceX. Anna flew on the Polaris Dawn mission with Jared. And then she left SpaceX and became an astronaut too. So they're just both astronauts. But Anil was an astronaut before Anna, but Anna flew to space before Anil, which is interesting. That's the all right. Okay, cool. I thought that was pretty funny. But yeah, Anil's scheduled for his first space flight. Once again, that's tomorrow. I mean, we could get into reading what Anil's resume is if you really want to know. And if you really want to know and feel bad about yourself, that's what usually happens anytime we read astronauts' resumes. How about just give you the top part? Anil Menon is a lieutenant colonel in the United States Air Force, emergency medicine physician, and NASA astronaut. He was a flight surgeon at NASA and then a medical director at SpaceX before being selected as an astronaut himself. Okay, another doctor, fighter, pilot, astronaut. Okay, all right, sure. Just, all right. Whatever. What did he fly in the Air Force? F-15s, 173rd Fighter Wing. Yeah, sure. Whatever. Telstar gifted a membership over there in the YouTube chat. Thank you very much, dude. Yeah, I don't want to read anymore. I feel really bad anytime I read astronaut. Oh yeah, and his wife's an astronaut too. Yeah, whatever. All right, whatever. It's fine. My wife's a software engineer. That's cool. That's really cool. Okay. Peter Griffin is a cowboy astronaut millionaire.
Discovery, go at throttle up.
JSpeed, you reminded me of something. I'll tell you in a second. Hey, Ish. How's it going? Watching from a newly upgraded PC. What's up, Ish? How you doing? Everything's good. Just been tracking 4014. Okay, what do we got here? Anil posted this on the 12th, so that was yesterday. Next Starship launch aiming for Thursday from Elon, and Anil says, I'll be watching from space. A little early for the launch window, what will be looking for an ascent plume. The ISS makes a near overhead daylight pass of Starbase at 5:42 p.m. Central, 141 kilometer slant range, 19 degrees off of the nadir, just port, sun 37 degrees up. Beautiful geometry, 21 minutes ahead of the launch. Oh, we are in for a treat, baby. We are in for a treat. Your wife is imaginary. Oh, that's good. That's good. Anyway, that's pretty sweet. You worked for one? Yeah, that's good too. And you know what? I'll click on this and we'll save this one for the rest here. But yeah, that MS-29 is scheduled to go tomorrow per next space flight. That's in 16 hours. I will be here for this. I'll probably get up here in the shop. Yeah, just a little ways before that to watch this launch. I want to share with you the funny. Luckily, nobody got injured. I've seen this. That's terrible. But we do have a Starlink, two Starlinks before that. One is at 5, the other one's at 9:17 tonight. But I'm gonna stop. We're gonna stop Space News in a little bit. I have to get off early tonight. No, I want to go spend some time with Bree. We didn't really get a lot of time to spend. We didn't spend a lot of time with each other this weekend because I was getting the mini split hooked up and stuff. So, yeah. No after hours tonight. Tomorrow, though. Tomorrow we'll do a nice long boy stream to make up for it. Okay. So, from spacecraft with advertisements on the side to this. SpaceX posted this on Saturday. Starship's 13th flight test is preparing to launch as early as Thursday, July 16th. Telstar, what are the answers? Oh, Chris got gifted one. Nice. Have you read the FAA statement on Flight 12? I'm getting to that. You should wake up at 4 a.m. to watch the Starlink launch. It is, Strickler, yes. Should I enjoy the NASCAR race at Chicagoland? It's cool that they're back. I didn't watch any of it. I know who won, though. But anyway, let's see some new footage from... Yeah, we can't listen to that. Did I see this? Yes, I saw it. Not interested in covering it here. Interested in this. This is good. That's a shot from Starship's a shot from Starship static fire. You should not sleep at all until Thursday's launch. No. I'm not doing that. Yep. Nope. Can you just ask SpaceX to launch at normal times? Well, they're going to launch Starship at a normal time. I'm fine with that. All Europeans watching Flight 13 at 1:30 a.m. Oh, as if you guys haven't been up all night lately watching the World Cup. Shut up. You're already on a crappy sleep schedule. What's one big rocket, all right? Give me a freaking break, dude. Give me a freaking break. No, I haven't been watching the work. Yeah, no, you have. Don't lie. Don't lie. That lying is wrong. Don't lie. Oh, yeah. Yeah, predominantly. We could talk about little mini hoppy. Yeah, we should do that. I just want to... Hello. Yeah, full heat shield. I'll get into details here in a moment. No, Colonel Sanders, you're wrong. Mama's right. Petrie, you gotta go. I hope you have a good night with the family. Thanks, man. Right on. Yeah, will do. I'm not gonna lie to you, Brian. I have a new show that we've been watching. I won't say what it is because we're only a couple episodes in, so I can't really give it an endorsement, but it's good thus far. I'll tell you more about it as we do more space news throughout the week. Are they planning to catch this one? No, they are not. So before we get into that, let's go here. So in order for Flight 13 to get on the books, we needed the mishap investigation from Flight 12 to come through. The FAA required investigation of SpaceX Starship Flight 12 launch mishap is closed. There are no reports of public injury or damage to public property. The Flight 12 booster did not come down where it was intended because of that weird flip. And subsequent grenading of the entire engine section. It came down way down range and it hit the water going extremely fast. The FAA oversaw and accepted the findings and corrective actions of the SpaceX-led investigation. The final mishap report cites two most probable root causes for the loss of the Super Heavy booster as heat effects on propulsion components during ascent and erroneous engine alarm system settings. SpaceX identified 4 corrective actions, including vehicle hardware and software configuration updates to prevent a reoccurrence of the event. SpaceX can proceed with Starship Flight 13 launch operations, provided all safety and other licensing requirements are met. The FAA will extend current limits on scheduled operations at O'Hare through October 30th, 2027. This action will help maintain safe and efficient operations amid ongoing airspace and operational constraints. Aims to prevent widespread delays and provide greater certainty for travelers. Yep, that's a word salad if I've ever heard one. All right, anyway. You know, that's good. That is a word salad. We're just going to keep being there. That's good to know. I really hope you are. Anyway, let's go here and go through SpaceX's blurb on Flight 13. So, Starship's 13th flight test. The 13th flight test of Starship is preparing to launch as soon as Thursday, July 16th. The 90-minute launch window will open at 5:45 p.m. Central. A live webcast of the flight will begin around 30 minutes before liftoff, which you can watch here and on X at SpaceX, the Everything app. As is the case with all development testing, the schedule is dynamic and likely to change, so be sure to check in here and stay tuned to our X account for updates. The upcoming flight will aim to complete similar objectives targeted on the previous flight test, which debuted the Starship and Super Heavy V3 vehicles, while also carrying next-generation Starlink V3s for the first time. Ooh. Ooh. Not sure if you got this one. Not sure. Could suggest this not when I'm reading this. Bro, it's right. It's literally right there. It's in the tab. Apologies if you've already covered it. What do you think of the Long March 10B capture system? It works. It works. It's really up to China to see if it's scalable. I'm not sure the long-term scalability of this. Romeo, just on a quick side note, like, so Long March 10B is a Methalox first stage, Hydrolox second stage rocket that China launched the other day, and the first stage came down and landed in this catch cube. It's this big, gigantic steel lattice, right, with 8 arrestor hooks. Well, 4 arrestor cables. They go kind of 2 this way and 2 this way, and they make a little peephole right there. The booster lands in that, and then the cables get taut, and then the booster has 4 arrestor hooks from an aircraft, from like naval aircraft, and they snag the cable, and the booster's just kind of hanging there. Now, I don't necessarily mind that. I'd be wondering how scalable that catch cage is. Like, are you going to fly a lot with this? If you are, I don't know. Like, I don't know how often you're going to be able to reuse something like that. It's a complicated mechanism that's on a ship at sea. That is, and once again, just an important thing to understand is that it's not like China won't pay for it. Like, of course they will. I'm talking about, like, how much downtime is this thing going to have? It doesn't seem like it would have a lot, but you got to remember the thing is brand new. And that's the thing, you know, I see a lot of people, Romeo, like saying, I read a lot of discourse about this on social media. A lot of people are saying, oh, this is so much better than Falcon 9. It's so much better than Falcon 9 because, you know, you don't have landing legs and it's much, you know, it's the vehicle can, you use that to deliver more payload into space. Yeah, you don't have landing legs, so you traded the complexity of landing legs and the mass fraction loss for landing legs for an infinitely more complicated catching device. Landing legs are a lot simpler than that whole catch mechanism. I don't think anybody can argue that. But what makes the landing legs more complicated is that they're on the rocket. Now, in the case of a rocket like Falcon 9, it makes perfect sense. Falcon 9 is designed for, well, the Falcon 9 1.1 and 1.2 architecture was designed with the landing legs. Right? If you miss the cables, you're toast. Dude, don't get me wrong. It's a good way to catch a booster. I'm not going to sit here and pretend like it's not. It's a good way to catch a booster. You know why? Because it caught a booster. Just saying. What I'd be really worried about is if they're going to, how you're going to be able to, like, what does China's plans look like with Long March 10? Are you going to do this a lot? This is a Long March 10B, which is a single stick variant of the straight Long March 10. Long March 10 is a 3-core rocket. So you're going to have 3 of these catch things downrange? What are we doing here? I'm genuinely wondering. Like, I'm not trying to be like, oh, I don't get it. No, I get it. I see what they're trying to do. Why? No updates on the rockers just yet, Pi. I spent most of the weekend putting a mini split in my shop. It's nice and cool in here, though, so we can make more progress on the car. Yeah. Now, Long March 5. Hey, you know if it gets difficult to keep it functional as a ship, they'll just launch it over land and build them on... Yeah, exactly, right? Hey, Graham, what's going on? Would you say that mass fractions are not the end-all, be-all of rocket program profitability? No, absolutely not. Yeah, I'd be really curious to see what their plan is with 10B, because I'm not sure the catching device is going to be scalable. Now, the reason why it works with SpaceX is because the catch device is already integrated into your integration architecture. The pad builds the rocket. It also catches the rocket. So therefore, it makes sense. Having a catch device that is separate from your landing architecture is... Yeah, I don't know if that's going to work really well for high scalability. But the flip side of that is that Long March 10B is a technological demonstrator. It's a tech demo. It's not supposed to be the end-all, be-all design. So, I don't know. Just food for thought. It's kind of hard to get news coming out of mainland China for obvious reasons. But, yeah, they did catch it. So, credit where credit is due. Personally, I would prefer landing legs. I think landing legs are way simpler to engineer than that whole catch cable system. But the catch cable system does work. It's not... I can't say that it doesn't. I wonder if there's a way to put the rocket together using the cable system. Mm-hmm. There have been leaks that 10C may have landing legs. Interesting. I don't see how Long March is any different than bringing barges back to port and lifting the rocket off with a crane, just a slightly higher payload. I think, remember, the context of this conversation is scalability. I think with scalability, minimizing GSE recovery stuff, i.e. just a flat drone ship with some sensing equipment on it, the ASDSs, is a much more scalable solution than those catching devices. Just personal opinion. And that right there is the reason why Falcon 9 has landing legs and why Starship does not. First time for Starship to have a full heat shield. I will get back to you on that. Zach again, 109-month resub. Klavic with a 91-month resub. Just saw the last Starship launch. It was very cool. Nice, dude. So this Flight 13 will carry V3 Starlinks. Real V3 Starlinks. Not the kind of jerry-rigged ones that we saw. Which is good. I'm wondering if those will have video cameras on it like the last time. Because the last time on Flight 12, SpaceX deployed the Starlink satellites out of the ship, and then they had cameras looking back at Starship as they were floating away. Watch Critical Path. Yeah, I already did that. The booster's primary test objective will be executing a successful launch, ascent, stage separation, boost backburn, and landing burn at an offshore landing point in the Gulf. There have been several modifications to hardware and software to address issues seen on the previous flight. At stage separation on Flight 12, slight differences in engine startup on the ship caused the directional flip of the booster to be off by approximately 90 degrees. The startup sequence has been modified to be more robust to timing variability and more reliably flip in the desired direction. 6 of the Starlinks will have cameras. Thank you. Have you covered Blue's new integration plans? If you have, what vid should I look for? Last Monday, Pigzig. Which is done to increase overall performance. After stage separation in the flip, the Super Heavy booster attempted its boost backburn. 5 of its 33 engines experienced issues when attempting to relight, causing the boost backburn to end early. The Super Heavy on this upcoming flight has hardware modifications to improve relight reliability, along with updates to the engine alarms and aborts to match the conditions seen in the multi-engine flight environment. Aldezert 70-month resub. Can I sneak in with a small 70? No. Only number 9s. And a number 9 large. It caused slosh. Yeah, only that's exactly what happened. Wouldn't it make more sense for China to have a chopstick landing tower too? I really was wondering if anybody was going to make that joke, Maslim. But, you know, thank you for confirming it. Nihon Hoppy. All right. Give me a second. Combined with the FAA report, the engines got too hot. They got too hot because that's what happens when you deprive them of propellants that are being used to cool the thing. They didn't. It's funny because that is 100% what happened, but they didn't. They said it in a very interesting way. He is supposed to be doing homework, but that was from a year and a half ago. Starship's upper stage primary objectives include the deployment of 20 V3 satellites, a relight of a single Raptor engine well in space, and then another controlled entry, descent, and splashdown in the Indian Ocean. There have also been several modifications. Billy! Tier 363 months. 9, but 7 of them. Yeah, that's fine. Yeah, see, that works. So you want 7 number 9s. It's good. With your 63-month resub. Yeah, it makes sense. There have also been several modifications to Starship's propulsion system to address the engine out issue experienced on the previous flight. Approximately 40 seconds after stage separation, Starship lost one of its 3 Raptor vacuum-optimized engines. The vehicle was able to demonstrate its engine out capability and reach its planned suborbital trajectory. Several hardware and operational modifications have been made to address the interconnected causes with additional reliability improvements planned in upcoming versions of the Raptor engine. Can I read that one more time? The vehicle was able to demonstrate its engine out capability. Okay, several hardware and operational modifications have been made to address the interconnected causes with additional reliability improvements planned in the upcoming versions of the Raptor engines. That's a lot of words to say, yeah, we fixed it. They sprung a leak. One of the engines had a leak. Like, once again, the footage doesn't lie. One of the Raptors popped the leak, and it started leaking propellant, and they shut it off. For the first time, Starship will carry V3 Starlink satellites to space, which aim to greatly expand the network's capacity and user speeds. As part of this initial test, Starship is planned to deploy 20 satellites, which will extend solar arrays and antennas and will attempt to connect with the larger Starlink constellation via high-capacity lasers. The Starlink satellites will be on the same suborbital trajectory as Starship and are expected to demise upon re-entry approximately 20 minutes after deployment. 6 of the satellites have been modified with a suite of cameras to scan Starship's heat shield and transmit imagery down to operators to continue testing methods of analyzing Starship's heat shield readiness for return to launch site on future missions. That's a ship catch. So the ship comes up and comes back down at the launch site and we catch the thing. Several tiles on Starship have been painted white to simulate missing tiles and serve as imaging targets in the test. You just test the whole damn heat shield, please? I'm not sure, Lev. Okay, painted white. Yeah, all right. Yeah, that's right. Okay, sorry. I saw white tile and I went, no! Yeah, okay, painted white. I should learn to read better. Several upgrades and experiments related to Starship's heat shield will... Several upgrades and experiments related to Starship's heat shield will also be tested to continue iteration towards a fully and rapidly reusable design. Multiple tiles will be attached to the metallic side of Starship's aft flaps, along with modified tiles and attachment mechanisms in the heat shield covering the aft skirt to gather flight data on different attachment options. Finally, Starship's heat shield will have load-sensing tiles to take measurements as the vehicle experiences higher dynamic pressure on ascent than previous flights, putting the added stress on the tile attachments in exchange for increased payload to orbit capacity. countdown. Flight director will conduct the poll, T-minus 50 minutes. LOX load starts at 37:30. LOX load underway, 37 minutes. Fuel starts at 35:25. Fueling, fast fill commences 34:48. Raptor begins engine chill on booster and ship, 21 minutes out. Prop load complete, 2 minute 50 seconds out. Ship, booster propellant load complete. Ship load complete, 2 minutes 10. 30 seconds, flight director verify, go for launch. Flame diverter activation at T-minus 17 seconds. 3 seconds, booster engine start command. T0, excitement guaranteed. So, as theorized, this is going to be more or less a repeat of Flight 12. But if they can nail this one, that particularly the Raptor relight in deorbit, that's going to be super useful. So this one shall be yeeted harder than previous ships have been yoked. That is a way to say that, yes. Can we just appreciate a starship gets filled in half an hour? Yes, we can absolutely appreciate that. What's the change that makes for higher dynamic pressure? No throttling down of the engines on the first stage. Yeah, they're pushing they're going to try to push as much as they can, but also complete the main flight test objective. So there's room for added, yeeting in there to keep going with the nomenclature that chat is using. If all ship objectives are met, do you think a catch on 14? Dean, I would like that. However, it's possible. I would think that 14 will probably be a booster catch and 15 will probably be a ship catch. Just my opinion. Yes, Grim. If it works perfectly, I think we will get a booster catch next flight, and then ship catch probably after that. But then again, getting the trajectory figured out for a ship catch, right? The ship isn't going to do one orbit around. It's going to have to stay up there for a second. In that time, SpaceX could conceivably safe the pad, right? And then you'd have to get the booster out of there, right? Get the booster away, bring the booster back to the production site, and then go for a ship catch. You're not going to land a ship on a pad that has the booster on it. Mm-hmm. I think they just want the numbers on a full yeet for the data outlier knowledge. They know it will survive. Most likely, John. That's probably what they're doing. They're not going to push it. They're not going to do a secondary test that could potentially compromise primary objectives. Starship needs to do that Raptor relight. The deorbit and entry has to be perfect. And the booster water landing has to be perfect. These two are if they get these right with the V3 ship on the second try here, that's when we can go for catching. Yeah, I really think they're going to be more methodical about this, especially as Star Factory starts tooling up. I'm pretty sure if this mission goes right, the next one will be a booster catch, and if that mission goes right, then the next one will be a ship catch after that. But, we don't want to catch our chickens before they hatch. Would you, though? Do you think they could set the booster on a stand next to the pad for the catch? It's not like a Starship catch requires anywhere as much thrust as the climb up it needs. Dude, if they could get a super heavy off the pad without sending people to the pad and put it on a transport stool and just leave it there and then have the ship come in, yeah, maybe. For a first try, I think that's risking a lot. Worst case scenario, you don't want to lose a ship, a booster, and the pad all at once, right? I would be methodical. As I would be more methodical, even though I want to see a ship catch just as bad as anybody else. Hey, EJ, do they still need a test to catch to test the catching mechanism? It'll be on the next flight. That'd be insane. They would need more time to look at the pad after the first catch. You think it's possible we see a ship catch on 14? No, 15. 15. I mean, eventually you want to be caught on a pad with the booster. No, I don't think so, John. I don't think so at all. No, I don't ever think they're going to try and catch a ship on a pad with a booster on it, and at least until like way far down in the program's development. SpaceX is building a ton of launch pads for a reason. Yeah. Didn't Gwen say that Flight 15 could be from the Cape? You thinking the ship catch, first ship catch at Starbase? That's a possibility, Drew. I wouldn't put that out of the realm of possibility. How long does it take to detank and safe a booster after a catch? You got to wait for the propellants to boil off, Finn. That does take a little bit of time. Now, the other thing that they could do is that you could set super heavy back down on the pad, right? If you set it back down on the pad, they could use the pad to evac the propellants and maybe turn the booster around quicker. Where I'm really at a loss here is how you're going to get the booster on the transport stand without people being there. You need people to do that. You need those guys running the SPMTs to move the booster away from the pad. The simple solution here is 2 pads. Get 2 pads working. And guys, it's possible. How crazy would it be for Flight 15 to launch from the Cape and then get caught at Boca Chica, or vice versa? I don't see why that's out of the realm of possibility. Guys, I'm fairly confident that the 39A launch pad is pretty much good. It's pretty much good to go. SpaceX wouldn't move ship and booster transport stools to it unless it was ready. But if they're willing to move, the way I see it is that if they're willing to move the transport stools to the Cape to start doing testing on the pad to test the pad systems, well, obviously the chopsticks have to work. Chopsticks are obviously work. You could catch at the Cape if you really wanted to. I don't think they will, but you could. It makes much more sense to launch from the Cape and then catch at Boca Chica, but I don't know. There's a lot of different con-ops that you could do here. I think we're going to get both. I think we're going to get launch at the Cape first. First orbital launch from the Cape and ship catch at the same time at Boca. Once the second pad comes online, goalie, the concept of operations for future SpaceX testing, that becomes a very blurry line. Like, it's going to be harder to predict it with 2 pads. Right now, it's super easy to predict. We have 1 pad and one ship. That's it. I don't want to test the other pad. I don't want to test the other pad at 39A with a launch before using it to catch. Yep. But as goalie was saying, Fluffy, there's no reason why you couldn't do both of those things. You could do a launch from the Cape, and then you could do catching attempts at Boca. Gwen, you've had chopstick issues after the static fire and also after Flight 12. Are they even going to be reliable enough to make catches the plan? They could cause ship boosters to not be able to be caught. I mean, I think that SpaceX will work that problem out, Gwen. But I also don't think it would be a bad decision to give Starship some landing legs, just in case. We've already seen that Starship can do a flip and burn and land on a concrete pad. We know that works. Just saying, could be a good idea. I'd be a little worried about the tiles during terminal descent, because the sound would be reverbing off the concrete slab that they go to land on. But a divert like that might not be the stupidest idea as well, just in case. Future versions of Starship will have landing legs because they'll be designed to land on other planets, right? So it's got to be in the pipe somewhere. Between launches, could they use the barge to move hardware that is built in Sanchez, then move to the Cape? That's pretty much what they're going to do, Headgame. That's pretty much what they're already doing. That'd be kind of cool, John. Yeah, that could work. Could they land a booster at the Cape? Too far down range, dude. Can SpaceX catch a ship from the Cape? It'd be better to launch from the Cape because orbits process westward, as Spoiled was saying in chat. It'd be better to launch from the Cape and catch at Boca if you were going to do 2-pad operations. That's why the shuttle often launched from Kennedy and landed in California. Not for that exact reason, but that's generally the idea. Yeah, Baz, yeah, you don't understand the testing period. It's not finalized yet. But yeah, I think that trying to land a ship on a pad with a booster sitting on it is probably not a good idea. That's probably not something you're going to want to do. Baron, that footage is super old. Can the boosters be caught at sea? No. So, I still have a tiered environmental assessment for SpaceX Starship reentry contingency operations in the Pacific and additional Starship landing trajectories here that we could go through. But I want to show you a Starship Chibi. Chibi Starship. Japan takes a major step towards reusable rockets. So yeah, on Friday, it would have been Saturday in Japan, they tested a experimental reusable rocket called the RVX. It was conducted in the city of Noshiro, Akita Prefecture, on Saturday. The 7.3 meter tall rocket total flight was about 40 seconds. It rose to about 11 meters above the ground, stayed in midair for several seconds before slowly moving another 16 meters horizontally, and then it slowly started to descend about 30 seconds after the launch. The JAXA official in charge of the test, Ito Takashi, said he was relieved to get to this point since developing the rocket took a long time. He added that JAXA wants to conduct a detailed review of the data obtained from the test. It's a little, look at it, little mini starship. It's so small. Chibi Starship. If you want airplane turnaround times, won't you need to land on boosters, basically? Not if you have 2 pads. You got to reload the ship with payload anyway, dude. Unless there's a payload dispensing mechanism that they're looking to build on the pad, John. No, absolutely not. You beat that problem with scale. Starship lands on an empty pad, you stack another Starship on the Super Heavy that just came back down, reload one with payload, bring it back when that other Starship is on orbit, and send it. This test was a major step for JAXA towards establishing a future transportation system in space. The technology is expected to help reduce costs. Rocket development and launches require huge funds. Conventional rockets have ended up being abandoned after finishing their one-off missions and falling into the sea or elsewhere. But the fuselages of reusable rockets are retrieved and used again. This helps save costs and increase the frequency of launches. Okay. Many institutions around the world have been trying to develop reusable rockets. Not trying. One nation has done it. I'm just saying. One nation did it in 1981. Just saying. Japan carried out a program of demonstration tests with an experimental vehicle beginning in 1999, part of its efforts to achieve rocket reusability. The rocket was called RVT. It was 3.5 meters high and 2 meters in diameter. Repeated experiments were conducted in which a single rocket engine would ascend to a height of 42 meters and then achieve a soft landing on the ground with reduced thrusts. These tests gathered knowledge for the development of reusable rocket engines. However, according to a researcher at the time, reusable rockets required high development cost, and it was unclear whether there was a demand. Yep. Japan, looks like Japan is subject to the same bull crap that we were for a long time. Well, the reusability doesn't make sense. There's no market for this. Shut the frick up. Given that the technical difficulty demonstration experiments using experimental rocket, given that and technical difficulty, they ceased operations in 2003. But then the U.S. firm SpaceX, led by Elon Musk, announced a plan to reuse rockets. They carried out repeated experiments in 2012. In 2014, Japan's Committee on Space Policy reached the conclusion that reusable rockets should be studied as an option for its long-term space plan through the 2030s. Oh, Nasdaq. That was 90s tech, though. SpaceX has been taking the lead with the Falcon 9 rocket. Yep, it first landed in 2015. This is NHK. This is like CNN for Japan or ABC or Fox or whatever. This is a major news organization. And it's pretty damn accurate for like mainstream media. I'm actually pretty impressed. This is all pretty damn right for a big news organization. NHK is government funded. Okay, so it's like BBC or PBS. Yeah, no, this is all right. Everything is pretty factually correct here. I just want to know more about the reusable rocket. Japan started developing the experimental RVX in 2016, an effort to newly acquire reusable rocket technology and put it into the next generation flagship rocket. It spent 10 years developing the engines that can be used repeatedly and a reaction control system. The agency said it has conducted 164 combustion tests on the same engine as the one used in the recent flight test and confirmed its safety and performance. In addition, JAXA is also developing a reusable rocket called Callisto, which can reach the upper atmosphere jointly with research institutions in France and Germany. JAXA plans to start a flight test using the same type of engine as the RVX with this rocket. Interesting. Okay, cool. So yeah, they tested a little baby hopper. Six string. PBS is publicly funded, not government funded. Do you like splitting hairs, six string? Because you're splitting a lot of hairs right now. Vaquero, the first reusable stainless steel second stage was actually launched from a volcano in Japan in 1967. It was abandoned after British interference. Really? Was it now? Anyway, it's a sore point right now considering the funding rug pull. Oh boy, yeah. Let's just take this awesome space news article and make it about splitting hairs. Yeah, no, that's great. I'm sure everyone wants to hear that. Are you picking up the sarcasm? Because I'll be honest with you, man. I'm laying it on pretty thick. Laying it on pretty thick, bro. Great, man. Great. Give it one more try for science. No, I don't think I will. Let's go to the draft tiered environmental assessment. Let's check this out. Let's see what's good here. Think you better take a look at this radar. What is it, sir? I don't know, sir, but it looks like a big dick. Take a look out of starboard. Oh my God, it looks like a huge pecker. Oh, where? Oh, wait, that's not a woodpecker. It looks like someone's rabbit. Yeah, Dr. Eagle. Yeah, that was a good rocket. It's a good design. It's just, it had asparagus staging in it, which is pretty cool. It's pretty cool, pretty nice. But, looks like a giant. Johnson! Yes, sir. Get on the horn to British intelligence. Let them know about this. Yes, sir. Chris, you're saying Little Chris, you really want to figure out how to do welding up in space for like spaceports and stuff like that if we ever get to that point. I just want to see a big rocket space yard up in space. All right, make it happen then. Figure it out. Wang, pay attention. I was distracted by that enormous fly. Willie, what's that? Wow, that looks like a giant. Johnson. Draft-tiered environmental assessment for SpaceX Starship reentry contingency operations in the Pacific Ocean and additional Starship landing trajectories. Okay. I wonder if this page was intentionally left blank. Oh, yeah. Yeah, okay. Yeah, sorry, I didn't read the fine print. All right. Where are the pictures? Where are the pictures? Let's go. Oh, okay. All right. What do we got? Proposed. All right. Let's see what we got. Proposed expanded Hawaii and Central Pacific Starship landing area. Okay. Previously approved Hawaii and Central Pacific Starship landing area. Okay. Papahanau'akeka Marine National Monument. And that word that I just said, 50 nautical mile buffer zone. Okay. SpaceX at one point wanted to land out in Hawaii. Look like a hiki. Come on, you want to lay me. Past the point. Mahalo. Go. All right, cool. Moving on. What's up, 619? How are you? Gesundheit. Yeah, sorry, I was sneezing. This is a great document. It talks in depth about the probability of Starship hitting whales. Okay. Just quick side note. I never realized that Wake was so damn close to Hawaii. But that does make sense. Does the ship get a lay if it lands in Hawaii? I would say yes. Like whales or whales? Probably the animal, not the country. It's not close. The scale is small. You guys are so fun. Sorry, I offended you. It's okay, Six String. You didn't offend me at all. I just... Look, there's time to clarify details, and I just don't think that really was the time to do it. During that article reading about Japan, so first of all, you guys correct me about the funding of the news station, and when I said, okay, that's fine, then you said... Chat tried to argue the difference between government and public funding, and then somebody tried to make that about politics. Do you see how this... See what I'm talking about there? None of those things have anything to do with the little Japanese hopper test. None of those things. See what I mean? Splitting hairs, dude. Don't worry about it. It's all good. But I'm trying a lot lately to not do that. You know what I mean? Let's go back and look at this. Okay, notional trajectory for Northern Pacific Contingency Landing Area and Starship landing at Starbase. Okay. Man. That's, okay. I personally think they should re-enter on the ascending node. Descending node re-entry looks like it flies, well, it doesn't fly exactly over Portland. That flies over Northern California, and then mostly through Nevada there, which is sand. Northern Nevada. And then it looks like it goes down a little ways past Las Vegas. Well, it's not near Las Vegas. That goes out over into Arizona. Yeah, I mean, if you're gonna fly a rocket overhead for landing, that's probably the place to do it. There's not a lot of people live in this area right here. Big things you got to worry about: Reno. Reno's kind of a thing. Salt Lake City's up there, so you don't really have to worry about that. You have Phoenix, which is right here. Albuquerque is basically right where my mouse cursor is. El Paso's right there. Yeah, I mean, it's not bad. Are they avoiding Mexico on purpose? I don't think so. It's a notional trajectory, so just... Are there any more pictures? Yes, there is. Remember, this is a draft environmental assessment, so this is the environmental impacts of Starship landing trajectories. I'm just in it for the Starship landing trajectories, to be honest with you. If it's dark, will heating become visible? Absolutely. I have it, Baron, yeah. The shuttle return was worse in terms of population overflight. Yeah, I don't want to talk about that, but yes. Sorry, I was just reading YouTube chat. Could land at Vandenberg. Yeah, it's almost like they built a facility there that's designed to... Oh, wait, wrong reusable rocket. Missed it by that much. Well, that facility ain't there anymore because it's going to be for starships. But anyway. 70 nautical mile distance from shore. So this is all the points where it gets close to shore, and these are all the different types of animals. There's the leatherback sea turtle, killer whale, southern resident, stellar sea lion. Where's Admana? I need Admana! Admana! Come here! The sea animals. Tell me about the... Well, I know what most of these are. What is a stellar sea lion? I'm going to go ahead and guess, because it says critical there, that it's probably an endangered species, whatever it is. But we can't piss off the turtles, homie. It's a sea lion that they think does a really good job. Night Viper, they're still removing pieces. I saw a huge chunk move through Lompoc that had a NASA logo on it. Please stop reminding me of that. Bro. Dan, you would love to see that re-entry from Montana. I, too, would love to have seen Montana. And drive a pickup truck. And have rabbits. Respect. No papers. No papers. Respect. It's a sea lion that eats all the salmon and poos on all the docks. Oh. Gross. National Marine Sanctuary right there. There you go. On a different note, they're surprisingly big boys. Oh! No, we can't kill this. That thing's too cool. It looks like it's the dog that swims in water. It looks like a doggo. That's a big animal. No, we should keep these. They're cool. They look like puppers. Sea titans. Ah! Look at the little boy. They're good. They're good puppers. Dude, a male sea lion is big. That's a big animal. Holy crap. It looks like a mutated potato. But it's a mammal. You're related to that more than you think. It's class Mammalia. Boom. An Mammalia chordata mammalia. Placentalia. Yes, I know what that means. Do you? It's a Mammalia class cruiser. Shadow Mask with the $5 tip. For my one vacation this year, I'm taking a trip to the Cape for the Nancy Roman launch on Falcon Heavy. Hell yeah, dude. Now we're talking, baby. Kingdom Phylum Class Order Family Genus. I remember that from science class. Oh, yeah. Yep. Gotta be careful. That's a big animal. Oh, look at the pups. Look at the pups. They are called pups. See? Oh, it's behind me. Sea lion. Yeah, pups. Yay. I guess when I read sea lion, I wasn't thinking of that. I was thinking of something different. They're also orca food. Yeah, I've seen the nature documentaries. The sea lion is not happy. Sea bears. I would say they're closer to being like sea dogs, I guess, Ian, but, you know. Look at that boy. Look at that boy right there. Look at how comfy he is. That is a comfy, comfy boy, all right? We can't disturb that. That's not okay. It's a comfy boy. I'm sorry. It's just a comfy boy. Like, there's nothing we can do about it, dude. Sorry, nothing we can do about that. We're just going to have to fly our starships around them. Funny, your cat does the same thing. Yeah, that's what I'm saying. That's all I'm saying. Considers you designated age. Okay. I want more pictures. So we're looking at all the funny pictures now, but I'm going to read through this for some homework. In Germany, we call seals sea dogs for a reason, though they're actually closer to bears. I read somewhere that rocket launches attract bears. The bears can smell the max Q. Okay. Sea Lion Appreciation Club Fund. Tell Star, thanks, man. Thanks for the £2. Yeah, so it looks like Starship is planning for a notional trajectory that goes on the descending node. So what that means, guys, is that, okay, so where are we on this trajectory? That's in the northern hemisphere, right? So that's above the equator. This type of trajectory, if it doesn't land in Texas, would go from the northern to the southern hemisphere. Any type of orbit that is inclined, meaning when the orbital plane of your spacecraft doesn't match the equatorial plane of the celestial body that you're orbiting around, i.e. your orbit is tilted, you're going to be traversing from the northern to the southern hemisphere because your orbit is tilted. By definition, you're going past the equator. Now, When you go from northern hemisphere to southern hemisphere, that the point at which you cross the equator is called the descending node. So a DN for short, just descending node. Simultaneously, you'll go down into the southern hemisphere and you'll come back up. When you come back up and you cross the equatorial plane of the celestial body you're orbiting around, that's called the ascending node, where your orbit intersects the equator. The angle of your orbit relative to the celestial body's equatorial plane, so your orbital plane over the equatorial plane, the angle at which you cross the ascending and descending nodes is called your orbital inclination. That is the degree tilt of your orbital plane relative to the equator of whatever you're orbiting around. Okay, so what if you didn't understand any of that? This thing is coming up, it's going to fly up near Alaska, and then it's going to come down over the Pacific Northwest, over the Rockies, down into the heartland, and land in southern Texas. The other trajectories that we've seen in the past so that would be a descending node trajectory. The other trajectories that we've seen in the past, that we've seen SpaceX file in the past, have been ascending node trajectories. Basically, where the Starship flies out over the South Pacific, right? It goes northeast, it flies over Mexico, basically directly overflies Monterrey, Mexico, and then lands in Texas. All of this draft tiered environmental assessment is dealing with a descending node approach to Texas. That's what I've really noticed here. I've not seen this before. And I'm not 100% sure why they would go with this type of trajectory. A guess would be that, maybe don't crash a Starship into Mexico. Probably be a good idea. So what this is looking at what a descending node approach architecture looks like and how that will affect the environment in the northern Pacific here, the Pacific Northwest, and out like what species that it could potentially compromise. Sea lion being one of them. Interesting. Habitat of particular concerns. Yeah, you obviously don't want to, you don't want to crash a Starship into some sea lions. Some of you spoiled, I see that you want that, but I'm pretty sure some people don't. But yeah, the big thing that I've been able to discern from this is that see this one right here, this is working off the coast of Peru and Chile. You don't want not you don't. I was about to say you don't want to land in the Galapagos Islands. That would piss a lot of people off. Just on a side note, this right here is not necessarily descending node trajectory so much, but the updated Starship South Pacific landing area is located about 200 nautical miles offshore, where species are not expected to occur in high numbers or densities. This is a contingency landing area, for what it's worth. But yeah. Okay, interesting. That's very interesting that they didn't they didn't do anything about the ascending node trajectory there. They didn't say anything about it. Now, it is possible that the ascending node trajectory, so flying up over Mexico and landing in Texas, right, is already approved. This is for notional descending node approach trajectories. But I think they would include that, interestingly enough, but I don't know for sure. I'd have to go actually read it. 3LRD, random orbit question. Does the change of tilt of the celestial body significantly affect trajectories of satellites? I.e., if Earth was to change its tilt by a degree? No. Not really. Not too much, dude. 3LRD, the main Earth has, so we'll use Earth as an example. Earth has two really main perturbing forces to cause decaying orbits, okay? One of them is the atmosphere. You know, the atmosphere, you fly through that, causes drag. It'll pull you back in. The other thing is orbital precession. Now, orbital precession is caused by, well, Earth is not a perfect sphere. It's close, but it's not perfect. Okay, it's called an oblate spheroid. All right, so what does that mean? Think about like if you had the Harlem Globetrotters and they had a basketball that was made out of jello instead of basketball, and they started trying to do the spin on one finger, the jello mold would just weeble wobble all over the place. And if they could get it to stabilize, it would bulge at the center, right? Earth does that. But it's not jello, it's molten nickel and iron. Yeah. We're just floating on the cool crust right now. That's why plate tectonics happen. Because we're floating on basically the rim of a gigantic molten nickel and iron jello mold. Now, because the center of Earth is a liquid, for the most part, it sloshes around like a liquid. Weird, right? I know. Weird concept. Like the jello mold, right? So that makes it so Earth's center of gravity isn't always necessarily at the geometric center of Earth. So if you took the North and South Pole and you took the equator and you made a point in the direct geometric center of the Earth, the Earth's center of gravity is not like in the same spot. It's not coplanar. It's just kind of floating around that point. And that makes Earth weeble wobble around. That weeble wobbling force creates orbital precession, non-uniform gravitational pull relative to the geometric center of the celestial body, right? And that will decay in orbit. Oh yeah, it'll pull you back in real quick. That's why there's decaying orbits on the moon. The moon stays tidally locked to us. So Luna, it stays tidally locked. The darker gray spots on the moon that you can see when the moon is up, right? That's where something bitch slapped the moon really, really hard and deposited a lot of schmutz on one side. So I'm going to say it this way to explain it in plain English. It's weight has nothing to do with it, but one side of the moon is like a lot heavier than the other side. It's not heavy, it's mass, right? There's no weight, right? Because we're in space. One side of the moon is thick. The close side is thick. The far side is not nearly as thick, right? So the moon always stays kind of pointed at us. It's called tidal locking. It stays pointed at us because of it, right? That makes decaying orbits on the moon. The moon's center of gravity is not in the geometric center of the celestial body. So stuff will decay around the moon. So it's not necessarily changing the axial tilt. Earth's axial tilt changes it doesn't change all the time. It just weeble wobbles around. Those precession forces, dude, are much more, well, not much more likely. Those precession forces cause orbital decay. They will cause what's called an orbital perturbation, which means something is affecting the spacecraft that's not the spacecraft. Orbital perturbations are usually caused by atmospheric drag, and orbital precession. There's also positions of planets, positions of Lagrangian points. This gets pretty complicated, really, the whole flying in space thing is kind of hard to do. But yeah, that's the idea, dude. It's not like, even if you moved Earth's axis, like if you change the tilt on the axis even a little bit, I mean, yeah, it probably screws some things up, but it's more about the precession. If you moved Earth's center of gravity further away from its central spinning axis, that would screw things up even more. To be clear, the orbits don't lose energy around the moon. They just get more eccentric until they contact the surface. That actually honestly depends on your argument of perigee and your right angle of ascending node at Aquilux. But if those numbers are right, then yes, sure. It depends. Depends on what type of orbit you're in. So 3LD, you really want me to blow your mind. There are satellites that use orbital precession to their advantage. A spy satellite, for instance, that's a good example. A spy satellite is in a resonant orbit called a sun synchronous orbit. What happens here is that this is a 97-degree retrograde orbit, right? You see spy satellites go into them all the time. And in this sun synchronous orbit, it uses the Earth's precession to basically make it so the satellite flies over the same spot at the same time in the sunlight every day. So they use the Earth's precession to basically make it so spy satellites go over the same spot at 8 a.m. every day. Stays on a very regular schedule. You have multiple satellites in multiple sun synchronous orbits. You could basically get 24-hour imaging of any spot in the world. And most governments have this at this point. Did I call plate tectonics earlier? Yeah. No, yeah. Plate tectonics, we're the only planet in the solar system that has it. Yeah, Earth's a little fire pisser of a planet, dude. Really, it's very unique compared to the other planets that we're around. Even the gas giants in the outer rim of our solar system. Earth's a very weird planet, which makes sense because we're here and we're weird. It makes sense, dude. Just saying. It's science. The more you know. Shape of the Earth exaggerated for visibility. Dude, now I'm showing that. Yeah, look at that thing, dude. That, like I said, Earth ain't no perfect sphere. Oh, it's a big jello mold of iron and nickel fun. Look at that. It's way exaggerated, but that's the idea. Is that with the oceans removed? Partially, yes. As you go further out, it gets even weirder. Yep. Yeah. Now, like, okay, here. We'll just do a quick cool thing about plate tectonics. You want to hear something nuts? That Starship Draft Environmental Assessment was talking about landing here off the coast of Chile and Peru, right? So on their west coasts, Peru's west coast and Chile's west coast and into Argentina, you have the Andes, right? The Andes mountain range. Actually, I mean, it basically goes all the way up to Venezuela, but you get the idea. The Andes here are the result of plate tectonics, but this is the only type of plate tectonics in this particular application here that exists on this planet. Now, look at what's just in the ocean. The ocean stays really shallow, and then it basically goes into an armpit of a freaking chasm right there, right? The reason why is because plate tectonics are pushing the entirety of South America west. They're pushing it west. And the Andes are the result of Earth pushing the entire continent of South Africa westward very, very quickly. So in plate tectonics, you either have like a plate that one goes under the other, like this, and it just gets deposited into the mantle, or you have one plate that goes over the other. What's happening with that plate right there is that the two plates, the one in the Pacific and the one in South America, are colliding with each other, and the South American plate is doing this. It's actually getting all bound up, and that's what made the Andes mountain range. Pretty cool, right? Dude, it's wild stuff. We're the only planet that has that. No other planet in our solar system has this. It's very strange. If you look at all the other planets in our solar system, that is very strange. That's anomalous, borderline anomalous behavior. Like if we were on another planet and we were looking at Earth, we'd be like, what the frick is going on there? That's very strange for planets. Like, that's a very weird thing to do.
Discovery, go at throttle up.
Hey, Taylor, what's up? 18-month resub. Uno Tracy, 24-month resub. Did you say South Africa? No, South America. I may have misspoke, but you get the idea. Yeah, dude. This plate is actually South America is getting pushed against this Pacific plate, and neither one of them wants to get deposited down into the mantle, so it just keeps building up and building up and building up. It's like if you had like a fruit roll up and you just tried to roll it back up. That's what's going on here. It's crazy. I don't know why a fruit roll up popped into my head. It's probably because I'm hungry. But yeah, I mean, there's other examples of plate tectonics right here, like how India, the country, India used to be attached down here somewhere, and plate tectonics decided to split it off of Africa and then deposit it into Asia. And it did it pretty damn quick, and that created the tallest mountain range on the planet, which is the Himalayas right there. So Mount Everest. Mount Everest is the result of a gigantic collision between the entire country of India and basically Western China. Oh yeah, it's crazy stuff. You could see where it crashed. Just a big continental Beyblade battle. I mean, yeah, basically crashed into it. That's the right way to say that. So the Andes are, yeah, exactly, six string. That's what I was saying. That's what's going on here. Hungry for chilies? Ride the Dente? He almost won, dude. Just saying. But yeah, I mean, you guys were talking about the Appalachian Mountains. The Appalachian Mountains were formed by plate tectonics from a long time ago. In fact, this is the result of collisions well before the continent was formed. Actually, what happened is this was the result. The Appalachian Mountains were the result of plate tectonics, and it was all kind of connected together, and then plate tectonics again split it apart not at the seams, at our modern coastline. There was at one point there was a coastline right here. You could see where it should be, and plate tectonics just decided it wanted to do what it wanted to do and split it apart. That's why if you look at the fossil record from like New Hampshire or Pennsylvania here, it matches the fossil record from Norway. You know why? Because those are the Appalachian Mountains. And the Scottish Highlands as well. It's all the same mountain range. It was just the same mountain range on a continent that got split apart built like a little while ago. I don't remember how long ago it was, but you get the idea. But you could see it's all the same mountain range. See that? Weird, right? Plate tectonics is cool, man. That's geology. That's good stuff. Geology is very, believe it or not, the type of rocks that are coming out of the ground are very important to how spacecraft fly up there. It's really important to understand what precession does, because if you don't know what precession does, you go to launch a spacecraft, you're going to launch it, it's going to go over the horizon, and it won't come back. You're like, wait, where'd it go? Where'd all the files go? Yeah, the Appalachians are some of the oldest mountains in the world. Yeah, they're older than the Andes. They're older than the Himalayas. They're older than the Rockies. Okay, so where is Atlantis? Oh, wait, here. I got it in my pocket. It's right here. Let me see. There it is. Yeah. It's right there. Yeah, yeah. Life is old there, older than the trees. I don't want to get copyright struck. So I'm changing the songs like a changing breeze. That's why John Denver says that in his song. Mother, I get to, boom. To the place I belong, Cape Canaveral, launching rockets, take me home, Banana River Causeway. That doesn't roll off the tongue as good. Exactly how old are you? I'm years old. I turned 38 the other day. That was weird. I don't like saying that. Dude, did we start dropping frames after singing John Denver? That's exactly what happened. YouTube, verify acquisition of signal, please. YouTube, you guys, it's just you and me now, YouTube. The Twitch ingest servers just took a dump. I can see it on the monitor. So it's just us now. Twitch is just YouTube, they're blaming you. Twitch is blaming you. See, Twitch did. Yeah, see, Twitch didn't want me to tell you my age for some. Okay, I was gonna make a joke, but you know, whatever. It's fine. You stated your age and the stream died. Coincidence? I think not. Just a minor correction. You said the major ranges where the plates crashed. It's more where the plates are crashing. Yeah, I mean, once again, yeah, the plate tectonics didn't stop. It's still going. That's a really good point. Yep. I'm 64, so I guess I'm a Commodore. No, you're not old, Bill. You're tenured. Okay, you're tenured. Differences. Okay, differences. Is the Twitch outage with the room with you right now? No. Twitch is back. Last week was pretty bad on YouTube. Really? You got a reacquisition of signal. Sorry about the hiccups there, dudes. But yeah. Science is cool, man. You got to learn about rocks to learn about how stuff flies in space. Isn't that neat? Oh, okay, Deadbringer. We can do that. Can you explain what that word means? Tenured. It means you're very experienced. You have a lot of experience in the subject matter. It's not old. It's tenured, dude. Okay? Splitting hairs again. Yeah, it wouldn't be this chat, Six String, if you didn't. That's why I don't take it to heart. But I am a SME. Exactly. A SME. I was talking with a friend today, Deadbringer, and he's like, yeah, my wife is a SME. I'm like, what? He's like, subject matter expert. I'm like, oh, yeah, I'm one of those too, technically. Yeah, Lava, that's right. Mm-hmm. Thanks for telling us the super secret you weren't going to share with Twitch. Oh, yeah, no problem, dude. Yeah. Tell them they look like they're crying. Are you crying, Twitch? I'm listed as in a few work documents as a SME, and you hate it. Ugh. Deadbringer, is that because everybody comes to you with... Yeah. I can, in a corporate environment, I can see how that would make me want to punch myself in the weenie. Like, you know? How could you say that? It's fine. Subject matter expert is the title they give you to make you feel better, but not pay you more. And on that bombshell, I think it's time to end. That was a good space news. I hope you guys enjoyed it. I'll be here for space news, same time, same place tomorrow. Don't forget, we have Soyuz launch, MS-29. Emil Menin's first flight to the space station on Soyuz MS-29 is happening in about 15 hours from right now. And if you're watching the VOD, it's probably already happened. If you're not, well, it's going to happen soon then. But yeah, MS-29, that's going to launch at 10:47 a.m. Eastern. So that, if whatever your time zone is, my normal start time, it's 2 hours before that. So I'll be here then, probably about 10:30, maybe. It depends on other things. I have to run some errands. Have you finished those errands? But yeah, we should be here a little bit earlier for MS-29 tomorrow. But I hope you enjoyed the Space and Rocket SME review. Great stream. Thoroughly enjoyed the VOD review. You definitely know you. It's so cringe. I hate watching myself, dude. Anyway. Yeah, if you want more of that, let me know. I don't want more of that, dude. I don't want more of that at all. But anyway, thank you very much for watching, guys. I'll see you guys all tomorrow. Probably, we'll say 10:30, net 10:30, 15 minutes before the launch, and we'll go from there. Thank you very much for watching, everybody. I'll see you guys tomorrow. Hope you enjoyed the Space and Rocket review. No after hours tonight, but we'll do after hours tomorrow. Have a good night, guys. Later. And thank you.